but we'll do our best. So what is a fire exposure analysis? Within NFPA 241 in Chapter 12 and 13, which is tall mass timber in large wood frame construction. For the most part today, we'll talk large wood frame construction. In those two chapters, it says if you're doing either of those things, you need to have a fire exposure analysis. And what qualifies as large wood frame, because I'm sure people are asking, it's going to be pretty much any podium building out there. But there's heightened area, like once you get over 40 feet, anything over 50,000 square feet is considered large. If you're under, I'm paraphrasing here, if you're under that 40 feet, anything over 150,000 square feet would be large wood frame. So that's the parameters in a fire exposure analysis. Is just going to look at safe egress out of the building and how to control spread to a neighboring structure if the building was to go on fire. So 241 asks us to look at that, look at both passive and active fire protection systems, do an analysis, and kind of confirm that those two things will happen, that we'll get both safe egress and we'll stop the spread of fire. So that's the baseline. And one last disclaimer here, none of us are claiming to be experts on this. This is a completely new operation. We're pulling from old codes and kind of cobbling things together, but it's a new requirement. So we're taking our best effort to try and tackle this, but we would love to hear from people that are listening. If you guys have other ideas about how we could go about this, that would be great. So let's get started. Where's typically the best place to start? We need to do this analysis. Like, Tony, what would you want to tackle first if you've been given a set of drawings to look at a building and say, hey, well, let's do an analysis on this?
Well, one of the first things I want to look at is where this building is located and what's adjacent to it, what are the exposures. And based on that, you need to look at if this building were to catch on fire, what happens to those exposed buildings. And NFPA, National Fire Protection Association, has a standard 80A, we call it ADA. Basically, it deals with recommended practice for protecting buildings from exposures. And it really is written on the building that's being constructed, protecting those adjacent buildings. We're using something that was never really initially intended to be used for a building under construction. That NFPA recommended practice is based on what would be a completed building, mm-hmm. and what would be maybe some rated or non-rated walls and what have you. But now we're using something, that a building that is under construction, which presents a lot larger fire exposure hazard, mm-hmm. and we're applying the concepts that are in that recommended practice on try to evaluate what the exposure would be to the adjacent buildings. And it's all based on heat transfer calculations, most of it radiant heat. There have been many, unfortunately, fires with these type of structures, which you've seen that the exposures actually do catch on fire because the radiant heat is terrific. So that's where I would start. Okay. I would start by looking at that standard.
All right. So if I may, Tony, so when you're talking radiant heat, because we get everything from college students to people with, 40 plus years experience or an engineering background or not, radiant heat, you're saying not flames catching something on fire, but just the total volume or mass of heat that can cause something else. The heat transfers and causes something else to catch on fire.
Exactly.
Right?
It's like the sun, all right? Yep. When you sit there in the sun, you can feel that heat. Or yep. if you sit next to some type of something that's hot, you can feel the heat coming off of it. Yep. Those are radiant waves that are coming off of that.
Or even a magnifying glass to light a leaf on fire. There's no flame there. It's just that straight heat. There's enough of it that causes a neighboring or adjacent structure to combust.
That's good analysis, okay. Yes.
Yeah. So, and then part of that ADA is looking about ATA, to be clear, right? Everybody, there's always confusion around ADA, the Accessibility Act, and ADA, not to be confused. When we look at ADA, the big factors are distance, so how close are we to a neighboring structure? There's also a component for openings and severity of the fuel load. Am I saying that right?
That's correct.
And then you look at those three things, and based on, if you are further away from the structure, you can have more openings and more of a fuel load. But as an adjacent structure gets closer, in order to be compliant with ADA, you'd need to have less openings, a different type of construction. Is that a fair analysis?
And that's fair. And those distances are extensive. If you have a wood frame building, as we're talking about here, and you have full openings on those walls, those distances to exposures could be in the realm of 200 to 300 feet away. And given today's atmosphere and buildings and how close structures are, that's just about impossible to do. So protecting those openings, protecting those facade walls against the adjacent buildings is really important. So you really need to have some type of a blank wall there and some type of fire resistivity to it. Now, typically these buildings go up, they're all wood frame. Basically, they may be just standard plywood. I would look for something a little bit more than standard plywood, maybe a fire retardant treated plywood. The structure that's holding that up would probably be fire retardant treated also. And then all the window openings would be closed. Because window openings I believe, will extend a lot. There'll be flames that from the burning building that lap out of that opening, and that puts just the radiant heat a little bit closer to the adjacent buildings. So it's really an important aspect of how to try to protect exposures. And that's the first thing I'm looking here for adjacent buildings, is to protect the exposures.
Yeah. No, go ahead, Jack.
I throw one comment that the windows themselves would not be considered a separation. They'd have to be plywood with FR plywood or something to protect. The windows wouldn't be a sufficient barrier.
Good point. So opening is not just meaning that it's wide open. It can, if it's that there is a opening that does not have a fire-rated, fire-treated material closing it up.
Correct.
Right?
That's correct.
Okay, so it's really going to be a balancing act, right? Because what the neighboring structure is made out of comes into play as well, right? So if you've got a brick building with fire-rated windows, I know that's probably unlikely, but if you had that, okay, the distance might be able to get a little closer. The number of openings can maybe go up. Is it kind of a balancing act where you're looking at materials, distances? Is the building that's adjacent, what the materials are there? Is there a sprinkler system there? Is it all that coming into play when we're doing that ADA calculation?
Well, it all comes into play. 80A, or again, NFPA standard 80A, really looks at the building, your building, right? But the exposing building, yeah, it's very important. If that building has a non-combustible exterior wall or facade, then obviously it can absorb a lot more heat before it passes through that wall and maybe ignites something combustible internal to it. But window openings in that adjacent building are very critical because the radiant energy will pass right through those windows. And it can ignite materials inside the adjacent building.
Interesting.
So sprinklers are important in that adjacent building, yes.
Yeah, actually, that's a good point, because if you think about it, I mean, you watch all these side-by-side burns they do and different studies of a room fire in 1940 versus today with all the basically chemicals that are in our curtains and furnishings and all that kind of stuff, how toxic they are and how fast they burn. So I wasn't even thinking about from that perspective. That heat goes through that window, and now you've caught the curtains on fire, and you've got an interior fire where the exterior wall isn't even on fire.
Exactly.
In a neighboring structure. We've been working through one of these recently, but that didn't even come to mind until you just mentioned that right now. So yeah, it's a challenging thing to figure out what are the exposures here. What are the potential exposures? And that's a great point. So the other component of this is safe egress from the existing structure. We want to make sure the workers can get out. Is that a challenge? Is it something that seems reasonably doable? What are your thoughts on that? Or Jack, I think
the stairwells are going to have to be built in their entirety. before the decking goes out. What we're going to have to do is establish them in a safe with rated hardware, give them a complete enclosure for egress. I think they're going to be important. It's going to be the best way to get workers out. We've seen pictures, we've seen things from other parts of the country where there have been some close calls, and this is where I think this code change has come from. That now we did only need one staircase prior. Now we need
not less than 50%.
Not less than 50%.
Yep.
So if there's 3 staircases, you're going to need at least 2 totally functioning and totally enclosed for safety.
You know, Jack, to back that up, we all seen the films, real life fires, and typically a couple have been in Las Vegas where construction workers have climbed down the outside of the building to get to a point where a ladder could get to them, a ladder company. And you just can't have that type of situation. So if you're going to build these stairwells and they're going to be exposed to the weather, you're basically going to build a non-combustible, probably concrete or CMU type of stair that goes all the way up with the protective enclosures. You just can't. You just can't rely upon the ladders, the fire department ladders, getting close enough to pull people off the building.
Yeah, and if we're talking about providing safe egress for people out of a structure that's on fire, we have to understand that the building is designed for, a rated, all the sheetrock being on, sprinkler systems active, and that's how many stairs you need. Now, yes, we have less occupants in the building, so we might not need as many stairs, or the size could be smaller that we could get away with. But at the end of the day, if we're saying that, hey, in a building without sheetrock and without sprinkler systems and fire alarm systems, that we need less stairs than we do in an occupied case, then I think that's, to me, that math doesn't work. So I kind of feel like, in my opinion, okay, everybody will have their own, but in my opinion, I can't see not all stairs being required when we're doing a fire exposure analysis. I think all the stairs have to go in, and they all need to be rated. Even though 241 says that not less than 50%, meaning if you have 2 stairs, you need 1 in. If you have 3, you would need 2. I don't know how you guys feel about that, but I can't see a space where I'd be comfortable with not all the stairs going in.
I just don't see 1 stair as workable because, you could be precluded from getting to that stairwell. And so you need to have at least 2 ways of egress off of any floor in that building, and preferably more, depending upon the length and the run. And a lot of these buildings, as they're being constructed, are open. So, you've got issues not only of the fire itself going from radiant heat-wise, but you could have wind pushing this fire. And so, Jack, you probably have a better handle on this as your background anyway, but I would think that at least 2, if not more, stairwells are going to be required.
I don't think it's specific enough because the configuration of the building could move the staircase. You have 2 staircases at each end of the building. Okay, put these 2 in on the far end. These people at the far opposite end of the building still don't have a second means of egress. Yeah. It's not specific enough. It says 50%. But what is that? If there's 4 staircases, 2 on one side, it's not going to cut it.
Yeah. Yeah. No, it's a good point. Yeah, you're going to be looking at more than just the number.
Right. The layout, the travel distance, the obstacles in between the 2 locations of where they're working to the egress, that all has to be taken as part of the factor.
Yeah, and I'm sure there can be a place where maybe not all of them are required, but to me, I would find it tough to see that you could do a fire exposure analysis and say that people can get out safely without all the stairs in. That's just my take on it. I'm not an engineer, not fire services like you guys, but I wouldn't have a comfort level without all the stairs being in and being fire rated. That's my take. Because then to Tony's point about, can a ladder get up to somebody? Well, can a ladder even get to that side of the building, depending on what the fire is doing, right? You might not be able to get a ladder close enough, or we're talking about a construction site even, right? When that's where all these other things in 241 come into play, because has somebody parked a boom lift in the driveway and now the fire truck can't get in there, right? These are these are all big factors that come into play. Water supply. This is where I think you guys both started to shine here. Access to water, volume of water. What are you looking at when you start to take a look at a fire exposure analysis? What are some of the things, Jack, that you look at when you first, maybe grab the drawings or go on Google Earth and see what's kind of going through your head when you're thinking about water supply?
Well, where is the water supply? A lot of the buildings you have to look at, where are the municipal hydrants? Are they building this in an area that the hydrants are poor?
When you're saying poor, you're talking about volume moving through it, gallons per minute.
Location.
Okay. Location.
Yeah.
Okay. Yep.
Right. Then the next part is, what do you have for pressure? What is your flow test? How much water can you get out of the existing system that's there? And that's where Tony did a ton of calculations on this project we're working on, just to see what can we get out, considering the residual pressure of 20 psi is required. And how far do we have to go to get sufficient water? Because these are just lumber yards in the sky. And once they start, they just feed on themselves. And need a lot of water real close, as quick as possible. That's really what it comes down to.
Yeah, I was going to say for a novice, Jack, just to go a little deeper on that before we move on, what's the big driver behind distance to the structure?
Most fire apparatus probably only carries about 900 feet of feeder hose. So they have to be limited to how close we can get without relay pumping and things like that. So therefore, you have to have it within a reasonable amount for rapid deployment of water onto the fire. Okay. If we cannot get rapid water on there, the fire's going to double in size every minute. Okay.
So we're talking about two things, right? So the time it takes to get the hose run from the hydrant to the pump truck. And now you got to understand that there's going to be folks listening that don't even understand this piece as much as it's inherent in the name. And then that pump is going to boost the pressure, and you're going to have hose coming out the other end. So the time to hook up, the distance you have to travel, and then you're saying depending on how far it is the pump able to boost it to what we need?
Right. Friction loss of the water rubbing on the inside of the hose creates a friction loss.
Okay. Yep. And then we care. So then coming out the other end, we're putting water on the fire. But where do we need to put water is the question.
Your best part would be protecting exposures first to prevent it from traveling. You need copious amounts of water to cool or to keep cool the exposures. The main thing is we have to slow it down. If we keep the adjacent buildings cool enough, it will buy time, right? With the amount of heat generated from these buildings, I don't think we're going to stop it. Mm-hmm. History repeats itself. You look at the pictures from all over the country. We're not stopping it. We can only slow it down to protect the people, get the buildings evacuated, and prevent a conflagration, really, is what you're trying to do.
Yeah, and prevent the neighboring structures, the adjacent structures from... So now, what if you're at a place where you have, let's say it's structures on three sides?
Getting apparatus and equipment into position is very important. It may have to be pre-staged. Some of the equipment may have to be pre-staged because with the radiant heat coming off the building, you may not be able to get in there to protect that exposure right away. But if you have pre-staged equipment or pre-piped equipment, it very possibly could just be charged from a safe distance and do its job to prevent the spread of the fire.
Okay. Now, you're trying to do all of these things simultaneously. Now, I guess you're going to prioritize, like you were saying already, you're prioritizing the neighboring structures, but you also might first be looking at, is there anybody in the building?
Of course, life safety is first.
Yep, so that's life safety. So assuming there's nobody in the building, if there was, you would start fighting the fire on the building, correct?
Right, to rescue the people.
Yep. And then next move, if that's not the case, you're dealing with adjacent structures first, and then turning and trying to, at the same time, bring down the existing fire?
Correct. The exposure would be the number two priority after life safety. If it's on three sides, it's going to be very difficult to get enough water in position to prevent it, depending on which way the wind was blowing, the velocity of the wind, what type of day is it. I mean, there's so many factors that it's just the incident commander would have to be, on his toes and just figure out, what's the best plan of attack.
How about water volume, Tony? Like, what does that look like? What do you need? How's that coming into play?
Well, the water volume could be extensive. Without the adequate amount of water, we're really in trouble. Give you an idea of the project that we're just working on. We have exposures on two sides, and those exposures are within anywhere from 40 to maybe 50 feet away. Obviously, if you go back to the NFPA standard on ADA on exposure protection, that really assumes that your building walls are already structured, fully fire rated, what have you. We don't have that, so we're putting up a facade of a limited combustible material or fire retardant material, which means we need to get water on those adjacent structures immediately. And to give you an idea, if you take something typically that might be 5 or 6 stories high, I've got 1,000 GPM spraying on the side of that building. And versus if maybe it was a residential house that we have in this other project, I might have upwards of 700 GPM spraying on that building. And the whole idea is to keep the side of the building wet. And just think of it this way. If the building's wet, then you know the temperature is below 212 degrees Fahrenheit. It's not boiling. The ignition temperature of wood is going to be around 450 degrees Fahrenheit. So you're doing your job.
And just to be clear, you're talking about that water on the adjacent structure,
on the
not
adjacent
on the building.
structures.
Yep.
Exactly.
Okay.
For example, if you had the buildings, as I alluded to earlier, that were probably 30 to 50 feet away, we need to protect those buildings. And to get water on those buildings quickly is going to be critical. To assume that the fire department can get there quickly and then set up hose lines and master stream nozzles to good on those buildings, that's time consuming. We may not have that time. So when we have close exposures like this, my feeling is that we need to have facilities in place that the fire department can quickly put water on those adjacent exposures. And that could be the form of pre-piped, what we call master stream nozzles.
Could you explain what a master stream nozzle is?
A master stream, if anybody's familiar with a fire truck, a lot of times they'll see on the top of that truck a large, look like turret type of gun. That's a master stream. And that can flow upwards of probably anywhere from 300 gallons to up to maybe 1,500 gallons of water per minute. And so basically, but that's pre-piped into the engine. That's already sitting there. What we're looking to do is have similar type of nozzles placed adjacent the building we're trying to expose, protect. And it would be within, probably 50 feet of those buildings or 30 feet of those buildings. And those nozzles would be fixed in place and aimed to protect that exposed building. And then it would bring a piping out to where the fire department could easily access that. Because as Jack alluded to, a lot of times you can't get around to the sides of the building or the back of the building. So this will allow the fire department to come in and very quickly hook up their hoses to these fixed place nozzles, if you will, to establish water flow on those buildings immediately should there be a fire exposure there.
Okay. So it's a piece of dry pipe going to that turret gun that you're talking about. The turret gun is in place, pointed onto the neighboring structures. There's a open-ended connection over near the hydrant that the fire department, would they just slug a piece of hose from the hydrant to that connection?
Be a quarter turn Storts, what they call it, Storts connection. It was just a quarter turn connection which locks the hose right onto it.
Okay, so they're going to run the hose from the hydrant or from the pump truck?
From the pump truck.
From the pump.
Increase the pressure.
Yep, to that Storts connection. And then it's already, that gun is already open on the other end.
Yes, it is.
So as soon as water starts going in there, it's going to come out and start spraying on the neighboring structure.
Right.
And understand that could be multiple guns, depending upon the size of the facility you're trying to protect, you may have multiple monitors on one side of the building.
Okay.
And then you have one more point. If you have a 4-inch main on the street, a 6-inch main on the street, a 12-inch main on the street coming by the structure, how much can you deliver immediately? Right? There may be some problems of having enough water. If you need 2,000 gallons of water hypothetically on exposure A, right, and you're only getting 900 coming down the street, you have a major problem at the get-go.
Yep. And then this thing is it's a zero-sum game, right? There's only so much pressure, and if you need to divide it up between multiple adjacent structures.
So much volume. It's so much volume.
Thank you. Yeah, you have so much volume, and you need to spread that volume between adjacent structures and the structure that's, under, what's the word I'm looking for? It's on fire.
Under construction.
Yeah. If you need extra in one place, that means you're getting less in the other, right? That's how it's working out.
There's only so much here.
So much volume.
You have to split it up the best you can.
Okay.
The best way to explain it, right?
Yeah, it is. And that's why the water supply analysis initially is critical. Just how much can we get out of the actual water supply system? Okay. Assuming there's a water supply system. You have other buildings that maybe in a rural area that do not have this. And it's not be uncommon to have fixed tanks and pumps and private hydrants that would be in place prior to construction.
Yeah. And not to leave the fire exposure analysis piece, but when we're talking about the distance of the hydrant and all these things, those are now governed by, in 241, the distance that the FDC can be from the hydrant is figured in there. And then what you're saying, Tony, is like there might be other provisions, whether we need to add a tank or is there a pond or a water source nearby that they can pump from. All these things are options, right?
Absolutely. You need to look at all those options, and this is part of the 241 analysis from a fire exposure. That has to be done early on. What's available?
And accessibility to that water. You might have a pond within 300 feet, but you might not have a solid ground to get a pump within 25 feet of it.
Good point. Yep.
So it may look good on paper, but it may not be feasible.
Yeah. And this is all going to time, right? How far away is the hydrant? Can we get to something? How quickly can we get water? All this stuff is time. So when we're looking at fire department response time, other than positioning of things, what are some of the things that go into figuring out how quickly it's going to take the fire department to get there and get water on whatever structure they need to get water on?
Well, you're going to start off with your notification. How long is it going to be before they're notified? That's why early warning is important. Now, goes through the dispatch. Retransmission by code is 90 seconds from a receiving station to a fire department, right? Average response would be within another minute, another 90 seconds for them to get to the apparatus. Then the driving time from the station to the location. What are they responding with? Are they responding with one company, 4 companies? What is the time factor? How much water can they get on that fire immediately? Now, do they have a life safety thing that they're not going to really care about getting water on it? They're going to be the first companies could be going right to rescue and evacuation. So again, it sounds like the more the merrier. The more people that are coming, the better off it is. And it's going to have to be very seriously planned with these types of buildings, especially during construction because of the exposures.
Jack, I think part of the pre-plan, when you start doing this type of analysis and working with the local fire department, pre-planning just how many pieces of apparatus, the flow capabilities of that apparatus and the manpower, I would think you need to look at that right up front so that if there is a fire from the automatic alarm, let's say that we place in these buildings during construction, what would be the typical response?
Well, if you're in the city, you're going to be probably getting 3 inches in 2 trucks in most of the heavy municipalities. But if you're putting big buildings in smaller communities that may only have an engine and a truck, plus they're running an ambulance, so there could be a depletion of manpower right there that they're on an ambulance call. It's a bigger picture of how many people are going to get there, and every municipality is going to have to be taken on its own merit, because what is the manning? What is the staffing? What are they doing? How much apparatus do they have, and how much manpower do they have?
Yeah, so you're talking about, from a construction standpoint, we'd call them resources. So what are the resources from personnel to equipment? And then there could be just straight distance too, right?
Correct.
Like how close? Are we 10 miles away or are we 2 miles away? That's a big difference. Is it a heavy traffic area? Is it a light traffic area? I'm assuming what happens if you're in like a call firefighter community?
They'd have to be toned out, get to the station. That, the timing is going to be getting, exponentially increased. And plus two, we're in New England. We have weather conditions. We have serious weather conditions that, and you get a good snowstorm, right? Getting the apparatus out. Are the chains already on the tires? They have to put the chains on before they go. I mean, there's a lot of
factors.
moving parts. Mm-hmm. And these are things that have to get looked at in the analysis.
So it could be a place where you see that the analysis is saying early detection is a must. Right?
I think early detection is necessary regardless, for the simple reason is the construction work is going to leave the site at night. Mm-hmm. It's going to be vacant.
Yep.
Somebody leaves a toy, who knows what, right? And now you get a fire ignite in the middle of the night. You're going to have early detection to get the fire department on the way, because the adjacent buildings are probably occupied.
Yep.
And if it gets too much of a headway, those people are in jeopardy in the adjacent buildings.
Yeah. So historically, where early detection is not required under construction, in kind of our new world here, it's looking more and more like that's going to need to be the case, especially in a denser urban environment. Right. Even though there are some, even prior to this new edition, there were companies that were, going with these systems, wireless smoke and heat detection and evacuation type systems. So that we were moving there anyway, but I think this new edition is going to push that even further.
This solidifies the foundation of it.
Yeah. And the other thing is the new edition also requires a person on site at all times from a security standpoint. So hopefully now you have human error when we're talking about a person. So all the more reason early detection, but hopefully with early detection and a person on site, we're going to get the desired result. But the thing is training of that person matters. The new standard says that that person that's there for site security needs to be trained in accordance with the section of Chapter 4, which gets into fire protection systems and things like that. So we're not talking about your standard Allied Barton security officer. We're talking about someone that has some level of knowledge. And hopefully those things are all adding up to meaning a quicker response time. Right.
It depends who's going to be responsible for that type of training. Are they going to have a new certification level on the state level? We don't know, right? Or he's going to flip back. There'll be a professional firefighter on detail. I mean, I don't know. And now we have to look at the cost factor of one to the other, which is going to be a pushback from the building industry, which is going to
be an eye-opener. These are some real costs, real heavy costs that will impact projects, no doubt. But that's what the standard is. So I don't, I think there's no getting around it, right? It's just the reality.
Right.
So early detection, response times, and then now you start alluding to materials, right? Where do we get to the point where all of these costs add up and it just means that, okay, let's just build it out of steel and concrete? let's do all fire rated? Like, do you guys think we get to a place where light wood frame construction for certain projects aren't palatable?
Yeah, it's really all dependent upon cost. I mean, there are new ways of protecting the wood. The fire retardant pressure treating has gotten a lot better, and really reduced flame spread and the heat release rate of the wood considerably. But do you make all the wood fire retardant treated? Probably too costly. Other things are intumescent coatings. Intumescent coatings are wonderful. Again, they're expensive. And by the time you figure the cost of coating all that wood with the intumescent coating, not only the material itself, but the labor, it may be less expensive to build out of non-combustible. So it comes down to a financial decision. And in a lot of cases where Jack was alluding to, maybe not having enough water supply, can't get the fire department there quick enough, maybe you're forced right then and there. Maybe that's part of this analysis. Look, I just can't protect this building wood frame nor the exposures. No matter what I do, I just can't do it. So you really have to look at a different type of construction method.
Yeah, because even Chapter 4 allows for, they've put a lot of provisions for putting fire protection in place during construction. It opened the door. It says that it doesn't need to be a 13D compliant system. It just needs to have certain, I think, spacing and things like that. So they open the door to give more flexibility to sprinkle as construction goes on. Obviously, we run into weather issues, and now you're doing a dry system and things like that. But you might have a place where, if, as Tony's saying, you don't have the water supply yet, and you need a fire pump, but the fire pump's not there. Now you don't, even if you did want to sprinkle a wood frame structure as it goes up, you don't have the water. Is that a possibility?
Yeah, and you have to establish that water supply up front. So if you are going to use, let's say, sprinklers, and it's going to be dry, a lot of factors to look at. Number one, where's the water coming from? And do I have sufficient pressure? So that may totally change your schedule of how you're building the structure. Possibly if it has a fire pump in it, those rooms have to be built first. That pump has to be put in service. And then as you build the sprinkler system, obviously you want to use the same piping that you're going to use for the permanent system. But understand that when you do this, that you're making that system dry, especially in New England because of heat issues. And by allowing it to be dry, you're now building up more corrosion in the piping. So that can affect the overall performance of the system down the road. So these are aspects to look at. And then the last aspect, obviously you're building a building. People are moving materials and equipment around. Obviously you're going to have issues where a sprinkler head's going to get hit or what have you. You're going to have inadvertent activation. And by doing that, you're going to have a lot more response from the fire department needlessly. So these are all issues to look at.
1,000%. I mean, I know some folks that have done the sprinkler systems locally, and what they were doing was they would shut the system. They would close the valve during the day when workers are there, and if need to on the floor, they could open it if there was a fire. And then after hours, like once everybody leaves the site, they do a pressure test, make sure there's no leaks, nobody hit anything, and then they activate the system again.
You can, but I understand too, there's a delay too in filling the system. These systems typically in a residential structure were probably going to be, if you have that type of structure, designed to be wet, because you're using a residential type sprinkler, which really wants to be wet. You want to put, as we say, the wet stuff on the red stuff immediately.
Yep.
A residential sprinkler is designed to protect the person in the room of fire origin. So now we have piping systems that aren't as robust as you would have, let's say, in a commercial type of application.
Yep. And
there's going to be a fill time. There again, there's a delay. I mean, is it an acceptable delay? Probably. All right. But is it a panacea? No.
So what's everybody's take? Do you think we're at a place where when we're doing this, and I think hopefully it's clear to everybody now that's listening, there's a lot of variables in here, and if there's some positive ones in one place that can kind of, it's like a balance, it's like a scale, right? We need this thing to be balanced. And as if there's positive things, that's good. You can have more negative things on the other side to get it to balance out. And is that really what this analysis is analysis of all kind of pros and cons and getting to a place where it is at a balance where everybody feels comfortable?
I would think so. This is something that needs to be done right up front. As the building is being designed by the architect, the fire hazard analysis is going along with it.
Yeah.
And that happens that early in the game because you're looking at all aspects, not only the type of structure, you're looking at the water supplies. You need to probably pull in a representative of the fire service as to what they cannot do for this facility. And that all comes into play when you design this building.
But the biggest thing that I see is if you take it and you're going into downtown Boston, you have an infrastructure already built. So you can be a little bit more flexible. Now you go to, Medfield, yeah, some small town that may not have the infrastructure. They already have a building designed, getting ready to go up. They're getting to this point. Is it too late? Because they may not be able to support it without a complete overhaul. And here they are already permitting. What do they do?
Yep. No, it's a real issue, and I think that gets back to the, do they end up having to start changing materials? Right. And now it's kind of late in the game to be doing that, so maybe not a whole scale change of materials, but does it mean that, hey, these wood framed stairwells, you know what, we really need to go block? Do we need to do fire treated? If it was one that wasn't fire treated on the exterior already, do we need to do fire treated sheathing on the exposed sides and then come in, 10 feet off of that or whatever, just to, I think it's at that point, if you're waiting that late in the game, like you're saying, Jack, which is, I think, Tony and y'all's message is this can't wait to that late in the game, because if you are waiting that late in the game, there might be a point where there are certain fixed variables where the fire department has a certain capacity, the water has a certain capacity, and there's no magic pill that makes those things better. So therefore we're stuck. And it could mean that the project has to change because the variables can't.
Right. It's a case-by-case type of scenario, and that's why this analysis needs to be done right up front.
Yep. And
the incipient part of designing the structure.
Yeah, and it's distinct. I think people need to be clear that it is a distinct analysis from the 241, the fire prevention program that gets put together, right? That fire prevention program is an important piece to the analysis working. The analysis is assuming that there's compliance with the fire prevention program. That has to happen. Correct. There's all these things that go into it about, and we're talking access, we're talking installation of standpipes, hydrants, all these other things that are already part of 241 that need to happen in order to make the analysis work.
Well, the code does say that the hydrants will be in place on the site prior to construction.
Yep.
So that a step in the right direction, but I think it's a little bit vague, because where is it coming from and what is supplying it? And there's a lot of variables there that, even though it states one thing, is there a sufficient supply to protect it?
Exactly. I allude back to some of your larger industrial facilities. And I'm going to go back to my early days, back in the early 70s when I was working with this. You built a large industrial facility. All of that was laid out beforehand. Fire water storage capacity, fire pumps, hydrants, all right? The type of structures. That was number one as part of the site. Before anything got built, before any foundation got laid, that got in place. And so a lot of that logic has to come and be applied here. We're talking probably 40, 50 years later, but 40, 50 years ago, commercial was looking at that. Industrial was looking at this.
Interesting. Okay. All right. Well, thank you both. This was quite an education. I'm sure everyone listening hopefully now has a better idea about what goes into a fire exposure analysis. Do you guys have anything else you want to, any other comments you might have before we wrap it up?
Make sure you start early with your plan. Don't leave this to the last minute because you could have a problem.
And I would agree with that. I mean, this analysis is something that needs to be done right up front, and understand there's a lot involved with this. And it's not just I want to build this building because it's a lot more cost effective to build it this way. Mm-hmm. It may not be in the long run.
Excellent. All right. Thank you both. Take care.